Usually people discovered Zenoh, and that's here I say the tip of the iceberg. It says, oh, super cool, I have a pub sub that can span end-to-end. And then they discover the rest of Zenoh, which is the distributed query, and that's where the real power, comes, and the realization comes. Wow. Okay.
Yeah. Well, I haven't yet discovered that, I guess. So the distributed query. Tell me a little bit about that.
Right. So the concept, it's actually fairly trivial, but the implications are quite interesting. Okay. So we have this concept of a queryable. What is a queryable? It's an oracle that it's around the network, and it simply tells that it provides data for, a given data set or a key expression, as we call it, okay? The key expression is where we're representing a data set in Zenoh. Mm-hmm. How does it provide data? We shouldn't care, but then we'll get there. And so then there is this get operation in Zenoh, which is how you actually submit a query. When you do a get, you provide a selector, how we call it. In this selector, you specify the data set and some predicates. And at that point, right, imagine the data set that you're specifying, it's really, logic, like a mathematical set.
Yeah.
And in that case, what Zenoh does,
it narrows it down.
It looks at the set you're looking for. It does a set cover with respect to the queryable that are on the network, and then decides what is the optimal set of queryable to which we need to route the query in order to get your data. And the consequence is that you don't need to know where the data is.
Yeah.
Depending on where you are on the network, we might route the
pretty magical. Yeah.
To different queryable.
Yep.
So that supports natively mobility, load balancing, and fault tolerance without you even thinking about it.
Amazing.
And then, if you think about a database, right, the combination of a subscriber and a queryable is the reading and writing side of database. And that's how we integrate database in Zenoh, like, Amazon S3 or RocksDB or InfluxDB or whatever. And a computation is just a queryable. And now, if you think again for a moment, map reduce. Okay, what is map reduce? You want to get a computation trigger on multiple nodes, and then you want to consolidate the result.
Yep.
But you can achieve that with queryable, because you can have multiple queryable essentially responding the same query, operating a different subset of the data, and then when the query is computed, we consolidate the data back or draw.
Oh.
So all of a sudden, in one protocol, you can deal with data in motion, pub sub, data at rest, so storages, and computation in a completely location transparent manner.
In a completely what?
Location transparent manner. So you do not.
What do you mean by that?
You do not need to know where the data is, where the computation is.
Yeah.
And as a byproduct of our routing algorithm, depending on where you are on the network, you are always going to pick the optimal place, either to get the data or to trigger the computation.
Yeah, that's so cool. Thinking of it like a distributed database is a very cool way.
That's the
that has all the computation, then it routes it all.
Correct, and we also have storage alignment. So imagine that the network gets partitioned.
Yeah.
If you have different storage, then whenever the network heals, the storage are realigned automatically.
Wow.
We have a pretty cool algorithm. And so that's the bottom of the iceberg that usually people discover that once they realize the full power of it, they say, wow.
Yeah. I see it. Okay. With this, how does it work? Like, I know it sounds like it's very complex. You have this very amazing networking.
The protocol, go ahead.
How does it, like, at a high level, how can I understand what's going on that leads to this really nice routing behavior and synchronization?
I mean, the underlying protocol is actually quite simple. And I think what allowed us to make it so simple is that we really narrowed the key primitives, okay? And in the end, what we do, right, we just route key expressionly on the network, right? So, and there are some technical, let's say, complexities on how to make this efficient, but the key concept are actually pretty straightforward, right?
So when you say key expression, what does that mean? Is that like a function?
Imagine a ROS topic, right?
Yeah.
Like CMDVAL.
Okay.
That's a basic form of a key expression.
Yep.
Now imagine that I have multiple robots. I could say bot1/bot1/CMDVAL.
Yeah.
So that's a key expression for us. It's a full key. There are no wildcards that represent just one data item.
Okay.
If I have multiple robots, I could say bot*/CMDVAL.
Mm-hmm.
So imagine that now.
So you can have wildcard queries in it.
So whenever you have wild,
And you could probably do some filtering.
correct.
So, that's super cool. Okay.
So because essentially when I talk about key expression, you realize because of wildcard, all of a sudden you're representing a set of keys
Yep.
as opposed to a single key.
Yep.
And you can do that on subscription, right? Because maybe I want to receive the sum debel from multiple robots.
Oh, that's so powerful. Yeah.
And in query, because imagine, right, I want to know the battery state of all my fleet of robots.
Yeah.
You could do get, right? You don't need get /bot*/battery level.
Huh.
That would trigger a distributed query
Yeah.
and get the data to you. Now, where is that data? Well, it
Could
depends.
be in a bunch of nodes.
Might be on your robots.
Yep.
Might be stored in a cloud, and you are closer to the cloud, because imagine I'm by the robots and I do the query. Maybe the fastest way to resolve it is straight on the robot.
Mm-hmm.
If you are in California and the robot is here, and the data is also stored on a storage, on a Google Cloud,
Yeah.
the closest storage will be on a Google Cloud.
Yep.
Do you need to care? No. And that's great, because you don't care where it is. You care to get the data, don't you?
Yeah. I guess I don't fully understand how it's working from this. So that seems wonderful.
Yeah.
And so you get to not care about where the data is actually stored.
Yeah.
Okay. So continuing, I guess, with the explanation of how it's working, like, I guess conceptually, what we're...
Okay, so conceptually with respect to how we figure out where the data.
Exactly.
Okay. So essentially in a Zenoh system, you have to think that we reconstruct a graph, okay? And over this graph, imagine that we have annotations like on a road.
Your metadata at
Yeah.
each node.
So let's make an analogy with when you're driving, okay? So when you're driving, and that's one of the way in which we make discovery very efficient.
Okay. Yeah, this is
When you're
exactly what I want to try to understand.
So suppose that you are going from San Francisco to Santa Monica, okay? So where do you look as a first indication? You look LA potentially, right?
Yeah.
So right, and
'Cause it's
once
pretty
you get,
close.
And then once you get to LA, you look the road to get towards Santa Monica.
Yep.
And the way to make this efficient, right? You don't get all the details in your mind, right? You refine it the closer you get to your destination. This is exactly how Zenoh works, okay? So imagine that now you have a graph that represents Zenoh nodes. Those could be infrastructural node like routers or application.
Yeah.
And we reconstruct a graph in which, like in the analogy that I made with the road indication, we have a generalization of this code information. So like in the case of the bot star CMDVEL, or bot if you want to get the battery status of a specific robot.
Yep.
Okay. Then at every hop we will know how to route your request, and this gets refined. And the closer we get to the target, the more detailed information we have on how to route it. I know this still sounds vague, but that's really how it works.
That's what you're doing.
And this is how we manage to really consolidate discovery.